Good afternoon, everybody. Welcome again to an episode of the Uncoder on Twitch with Qork. If you tuned in last week, you know that we covered snowology and everything you need to know about snow code, and then jumped into a demo of a game that we built in Qork. Today, we're going to pick up on that. We're going to focus on the AI elements of it, how we built the concept of playing against the computer in the game, like any good old school 8-bit game would allow you to do. And then also dig into some of the ways that you can debug some complex applications and server-side logic and all that good stuff in Qork. So I opted to keep the same background and same shirt as last week, just in case anyone on the team wants to combine this into one. Focus off when all of a sudden my head shrinks halfway through the video. All that being said, let's just dive right in. So I'm going to share for the rest of the Twitch. And here we go. So the first thing I'm going to do is I'm just going to play against the computer and just show you how that looks from an end user perspective. So once again, skipped all the login steps that we went through last time and get right to starting a game. So this time around, I'm going to choose a one Qorker game. So I'll start up a new game, and here we are. You might recall this. And I'm just going to go really quick here. I'm going to make a turn. Boom. Computer just made their turn really fast. I'll make another turn. Boom. Computer does the same. Make another. Whoop, computer's taking a little bit longer each and every time, you might notice. It's crunching a little more numbers. And then let's just end the game, because I don't think you want to sit here and see me play it the whole time. But just wanted to get the point across that that's what it looks like. I make a move. Next thing you know, the computer makes a move and it comes right back to me. Application refreshes. Everything is good to go. So with that being said, let's dive in, talk a little bit about how that works. How does the computer actually figure out what to do, particularly without any code? All right, so for that, I'm going to jump over to an API module we have called Turncom, the computer's turn. You'll see, if you remember from last time, a lot of similar components, which is actually not a good thing, because that means I repeated myself. And as folks know, in good software development, there's a concept called dry. Keep your config just as dry as you want to keep your code, even though we're in the Antarctic and it gets a little bit wet here. Keep it dry, which means don't repeat yourself. So I did repeat myself, and I wish I hadn't, and I did want to try to refactor it before the Twitch, but it worked, and that's what's most important. So some similar features that we saw when calculating what to do when a player takes a turn. A lot of the same concepts exist on the computer's turn, but done in a little bit different of a fashion. So this, again, is the module that's going to get executed when the computer's turn is taken. And I just want to go through a few things that happen. So first and foremost is we have some server-side validation, which is a very simple decision that says if the game is in progress and it's the computer's turn, then let's get started. Which all it is to say is, if the game's over, we don't want the computer to try to make a turn and mess up the integrity of the board. And if it's also not the computer's turn, we don't want the computer to come in and steal your turn. So, and of course, we're also validating that in the game application or in the game module, the UI that we just showed. But you always want to validate server side as well as client side, because you can never trust what that client is doing, whether it's somebody in their browser, some other system that's talking to it. Doesn't really matter. You always want to really validate everything on the server. So once again, we're just going to double check that the computer is really allowed to take a turn in the game. Okay. So the next thing we're going to do is now let's actually dive through and see, well, how are they going to decide what move to make? Okay. So basically, look, I'm no expert in AI, and I'm sure there are better algorithms to figure this out. But effectively, what I wanted to do is say, in the end, the goal of the computer is to take a turn that they don't lose. And in theory, and ideally, I should say, take the best turn possible. So in order to define what the best turn possible is, I'm just using a very simple criteria that says the least number of other blocks that fall down. Because remember the concept where if I hit a block, let me just pull the screen back up again. If I hit a block like here, then these two will fall because they no longer have support. So my goal for the computer is pick a move that results in as little other things happening on the board. Now, when I was going through the rules last time, I did say that you could use that concept to your advantage and try to make a lot of things fall and leave your opponent with very few decisions, but ideally decisions that will result in them losing. I'm not going to that level of complexity with the computer. I'm merely saying don't lose and don't lose by knocking the least amount of blocks down when you take your turn. All right. So in order to do that, rather than just starting at the top left, originally I had built it so it starts at the top left and work its way across. That got kind of boring. It worked, but it got boring where every time I took a turn, I knew what the computer's next turn was going to be. It was going to be the next one across the first row or second row and going sequentially through them, that they didn't lose. And it just made for a more computer feeling game and less of an actual intelligent computer. So I said, hey, let's just randomize it. So at least it seems like something else is going on here besides, again, just systematically going through the list. So that's what happens first, right? We're just going to effectively take our board. We're going to create a random number as an attribute. We're going to sort that and we're going to get rid of it. And then that's going to be our board. So this is effectively just a way to sort the board in some random order and then get going. Okay. So the next thing we're going to do is going to be very similar to what we did for the player's turns. Okay. So this is going to do the same. It's going to hit it. It's going to see what to check based on that hit. And then it's going to loop through and see what falls. Those were more or less the exact same steps that we took on the front end when a user took their turn. Okay. But there's a few different things that are happening here as well. So one of the things that's different is this data workflow turns. Okay. So after we take the full turn, which is marking the one that's hit, traversing everything, seeing what else is hit, and coming up with the final state of the board, then we're going to basically store that turn. All right. So we're effectively just grabbing the board. We're also going to calculate how many blocks fell when the computer took that turn, right? So there's this thing called size hit, which was effectively a count that I took at the beginning of the processing to say, hey, on this current board, how many blocks have been hit or knocked down? And then effectively what I'll do is I'll count the size of the number of ones that are hit in the new board, and then just do a simple math minus the what has been hit now versus what was hit originally. And that tells me how many blocks are down in total, which I will use later on to help me determine which turn I want to pick for the computer. Okay. The next thing that's a little bit different is this rule turn. All right. So this happens after I've kind of calculated that turn and added it into the list of the attempted turns I've taken. And then I'm going to do something which effectively says, hey, if the game is still in progress and only one block fell, then I'm done. Right. I want to pick that turn because, again, my rule for success, my success criteria said they don't lose and the least number of blocks fall, which is obviously I'm going to hit one. So one is always going to fall. So if only one fell and the game is still in progress, I've met my goal for what I want the computer to do, and I'm done. If the game is not in progress, which means the first random block that I hit resulted in the computer losing, obviously we don't want to pick that turn. And if the number of blocks that fell were greater than one, then there is a potential that there's a better move out there by the definition of better of least number of blocks fallen as possible. So I want to continue looping through the board and trying different combinations of XY coordinates and running that same logic. So that's effectively what happens as you go through. When all of that is done, then it's just a matter of picking the turn. Okay. So now I have, again, as many turns as I took to more or less hit that criteria of one and in progress, or potentially you can get yourself obviously to a state of the game where it's impossible to hit one block and have no other blocks fall. So we may never find one with only a size difference, that size hit difference I had. We'll never find one that's only one. It's possible. So we're going to run through every possible combination, and then we need to pick the best move based on that, again, being determined by least number of blocks fallen, game is still in progress. So that's more or less what this does, right? It's effectively going to split between the ones that are in progress and the ones that are not. So effectively anything coming out of this filter line, so we said, hey, is the status of the game still in progress? If it is, then this is really what we want to take, right? Which it says, hey, if the size is greater than 0, so this is going to give me an array, right? So this is an array of every turn that we took. I'm going to filter that again by progress. And I'm going to say, hey, how many of these turns still resulted in something being in progress? If that answer is greater than 0, then I'm going to use one of the in progress ones. If there were none that are in progress, that means that the game is over. So I'm going to use that as my, or one of those potential, because you can have multiple different hits that could result in the game ending. I'm going to pick one of the game ending ones, even though it doesn't really matter, but one way or another, okay? And then effectively what I'll do there is I'll take whichever set of turns ends up being the one I need, either a set of ones that are still in progress or a set of ones that the game is over. I'm going to order it by the size hit, which is that difference, to say how many of them have actually knocked down. And then that's going to be my turn. So that's all I have to do to actually pick a turn once I've calculated them all. Okay. And that's it. That's an AI really in Qork. Again, it's the same, because what is it? It's artificial intelligence, right? So I took the logic that I needed to apply to whatever the opposite of artificial is, real intelligence or human intelligence or non-binary intelligence, take that same logic and just automate it on the server. So I was able to, even though I copy pasted versus having some reusable module to execute a lot of this logic, it is more or less the same logic, just with that kind of looping mechanism and some other stuff to pick out what the best turn is. And in a sense, right, isn't that what you're going through in your head? You might, as a user, when deciding to determine which block you're going to hit next, you might run through and figure out which is going to be the one that's going to result in you not losing and the least number of blocks fallen. So there it is. That is an AI, really all it is to it, within Qork with absolutely no code. So now that we've seen how the computer, I just got a good question. I love this question. So does the AI ever win? And I think this is the greatest question, because I do want to show this. So I'm going to go into the production environment where we launched this a year ago when we first built it. All right. And I am going to very quickly grab, please no one look at my screen, get off that, the DQI, where is it? DQI. All right. I'm going to grab that link and I'm going to log into our production environment. And I'm going to go to the rankings tab. All right. And sure enough, if we look up here, our computer, since the inception of this game, is 80 and 23, 80 wins and 23 losses for a 777 win percentage. And you can see the folks who are ahead of it have really only played like one game and happened to win. So basically, for as simple as the AI it's effective, right? It's beating humans consistently at this game. It's no Deep Blue. I'm not going to go put this up against Magnus, if he decides he wants to play some Don't Qork the Ice instead of chess. I'm not going to expect this AI to beat him, but it has done a pretty good job of beating all of us at Qork. So again, it's because that was the goal. The goal is basically don't lose, right? And I think if you think of sports analogies, they say the best offense is a good defense, right? And that's kind of the concept here. The computer says, I just don't want to lose this game, and I'm going to do it. I can systematically, very quickly figure out what means I don't lose, and they just let you make the mistake. I mean, I think you hear that in tennis too. Just get the ball back over the net, and eventually your opponent's going to hit the ball into it or hit it out of bounds, and that's not the worst strategy. So there you go. Now, okay, so we've seen how to build the front end, player versus player, Qorker versus Qorker. We've seen how you can easily adapt that into an AI and have an interactive game playing against the computer. And I think this is a really good time now to talk about, we've talked about how to build it, but honestly, throughout the whole process of creating this, the building wasn't the hard part, really. The hard part's debugging. And I think anyone who's built any kind of software knows how much time and energy goes into debugging. Right? Because even though it's no code, it's still software, and software needs to get debugged from time to time. Because there was a lot of complex logic and everything going into this. So I want to show now some of the ways that I had went about debugging this application while building it, and obviously all of which is very transferable to pretty much any use case or any application you're going to build within Qork. Okay, so the first thing I'm going to show, it's nothing that's going to be new to folks who've been either building it on Qork or tuning into this channel. We've talked about the server-side execution testing a few times, but I do want to bring it up again because, of course, this Turncom API can be executed via server-side execution testing. All right, so all I have to do in this case, the way that this API is built is you just provide it with a submission ID, and that submission ID would be the ID of the game, which is this ID up in the URL, the unique identifier for the submission that's storing, the players who are playing, the status of the board, so on and so forth. And that's the only data you pass in. And then you run all the logic that I just said. So as you can see here, I've got one pulled up already. I had taken a game and I just ran through it. And then, as we've shown, you can step through step by step every single action that's taken throughout the computer's turn. So this is a great way, of course, to see an end-to-end execution of how it goes. Everything from, does that initial validation that we showed apply? In this case, it does, and it allowed me to continue through to each iteration of the loop that's necessary to figure out what turn needs to be taken, all the way to the end when the turn is actually done. Okay, now just to show, if I hit execute again, then nothing happens, right? Rule init runs and nothing else after, because since I'd already executed that submission when it was the computer's turn, I do it again and the computer can't go because it's no longer the computer's turn. They already took their turn. Okay, so this is obviously going to be great and super useful in anything that you build that's API driven. But one of the problems here that I found using this was when I take a turn on the UI, the computer immediately responds back to me, right? Because the process in the game says, once I'm done, tell the computer to take their turn, and then they go. So one thing I can certainly have done here was create a new game, make a turn, and disable the computer's turn. So find that plugin in the game down here somewhere. Plug com turn. I can come in here. I can disable it, which means when my turn's over, this won't trigger the computer taking a turn. And of course, I did that from time to time throughout development. But of course, that's not necessarily, maybe not of course, but that's not always ideal, right? Because in order for me to test that, I need to break the front end, which, if I'm the only one playing and I'm just in early development, that's fine. But I've done a lot of work already to get the whole front end working. I don't want to necessarily have to go break something or turn something off, and I'm going to forget to turn it on later, potentially. You never know. So I'd love to be able to test this without having to make any changes to logic that's already working. Now, one of the other things is thinking about, as I said, I reused a little bit of logic here rather than moving it off to something reusable. And I also built it so you only pass in a submission ID. So the turn is always acting upon the data that's associated with the submission rather than directly passing the data of the submission into it. So one good, I think, improvement that could have happened to this application is rather than just making this API be where all the action happens, you could have a submission ID, call this with the submission ID, use the data from the submission to execute another module where you pass in a board and you pass in an X and a Y or something like that, and then it does all the logic. Had I done that and been able to pass in entire request objects inclusive of everything that this API needs to run its turn, which is a nice way to remove dependencies and things like that. And it's actually not the worst architecture, but I didn't do it. Had I done that, I could have just used the server-side debugger. I could have come over here. I could have entered whatever board I want as JSON in any given state, and I could run the logic. But again, I decided to try a different route, which was just throw this ID in and let it happen, which means it wasn't as easy necessarily to test. So then how could I use server-side execution testing if I don't want to mess with my front end and have the computer automatically respond? How am I ever going to get to a state then when it's the computer's turn and I want to test what they're going to do? So this is where submission revisions come in. Okay, so I think it was a couple weeks ago when we had Eric Ma on to talk about, what was it, enterprise view. He made a comment along the lines of, folks normally think of submission revisions as a debugging tool, which, spoiler, he's kind of didn't spoil this episode, teed up this episode perfectly to get into how you can use submission revisions to debug. But what was cool is he showed you how you can actually use submission revisions as a feature within your production application. right? So there's a ton of things that you can do with submission revisions. Again, a submission revision being for every change to your data, we save a copy of the data at that point in time, right? Which is huge for compliance in a lot of the industries that applications in Uncoder are being built with. Great for debugging, great for using it as features as well. So in this case, again, we're going to use it as debugging. So since every single change of the data results in a new point in time copy of the submission, that means that every single time we have made a turn, we've saved the state of the board at that turn. So every turn actually gets a revision of the submissions, right? So again, Eric said this could be used to build production features. I mean, one thing we could do with that is we can actually build a history of all the moves. That could be a feature we can add to the game. Hey, do you want to go back to any game and see the moves that every single person took? You can pull that directly from submission revisions because it'll have the current player in the submission, and it'll have the turn, and it'll have what the board is. And then getting even fancier with the UI, maybe even consider watching a replay of a game where you can effectively just kind of loop through the submission revisions and then show the board dynamically updating for each and every revision, and effectively just go back and watch any game. I mentioned Magnus Carlsen from chess earlier. That is something that a lot of chess apps have, right? You might want to go back and watch a game from the World Chess Championship. Why not go back and watch a game from the World Qork Championship? All right, so lots of things that you can do with submission revisions. Again, we're going to focus on it from a debugging perspective here. So first and foremost, let's just show submissions. So this is, using a nice little JSON formatter plugin for my Chrome, or extension for my Chrome, just hitting the submissions API for the submission of a Don't Qork the Ice game. And you can see here, these are all the games that ever happened, right? So let's just start there. Now, let's say we want to go and we want to look at the revisions of any one of these games. So what I'll do there is I'll grab the submission ID of the game. Actually, I think it was this one I wanted, right? I think it did it already. Great, it's over here. I got these tabs lined up for you. So now here's the submission itself. So now I'm just looking at a single submission. All right, so that was just taking the submissions URL here and tacking a submission ID at the end. Very straightforward. Now I can see just that one submission. Well, now let me go look at the revisions of that submission. So I hop over again, and now you'll just see we tacked on the word revisions after the submission ID. So now here is each and every revision that happened. We were on turn 3. So not surprisingly, there are 3 revisions of this game. Okay. Now you'll notice there isn't any data in this endpoint. And Eric talked a little bit about how you can actually use metadata to store some more data in this endpoint itself. But one of the reasons for that is you can imagine as you have millions and millions of submissions being captured in an application, and then multiple changes to each one of those submissions, the volume of that data is going to grow tremendously. So rather than storing all of that data inside of the database and having a ton of additional records, Uncoder stores that somewhere else. And then when you request a specific record, we're going to go pull back the data for you. It's also great for another feature that I think we've covered, which is called worm storage, which is write once, read many. Important in certain highly regulated industries where once the data has been written, nobody can change it. And that's also a benefit of the way that submission revisions were built within Uncoder, where the copy of the submission where it lives is in a state where it's not going to be written. Okay. So now that we've got our revisions, if I wanted to look at a specific revision, I can come over here, grab the ID, and pop it up. So in this case, I actually grabbed number 2, or the second one in the list, and this is my revision. And sure enough, you'll see this is turn 2. If I come back and I were to grab the ID from our first revision and drop that ID in, you'll see it's turn 3. Oh, sorry, I don't have this sorted. I have this sorted in reverse chronological order. So 3, 2, and then that would mean that this should be number 1, right? So here you go. This is actually every single turn that people took. And again, you can do some pretty cool stuff with that if you wanted. Again, though, we're going to do it from a debugging perspective. So now that we've actually gone and we've said, all right, let's grab, I'm going to go back to turn number 2. So now we have the data for turn number 2. What can I do with this? Right? Why is this going to be useful for me debugging? So I will tell you, throughout the entire process, I would test by making a move against the computer, seeing what it did. And of course, in the beginning, it never did the right thing, right? It would just not pick something. It would pick something that ended the game. It would pick the cork, which obviously should never happen, right? It doesn't always work. Or I'm in a specific scenario and I'm clicking a button to force a move and it didn't always happen. So I might want to replay that exact state and see what happens again. So how would I actually use submission revisions to do that? So what I could do here is, why don't I just grab all of the data from the submission revision? Okay, grab that. And let me just drop it into a little JSON linter and make sure it looks good. It's valid JSON, so I copy pasted all the right stuff. And now I've got this turn. So I'm going to hop over to Postman, which is obviously an API testing tool, and I'm going to use it to create a new submission in Uncoder. And I'm going to create a submission of, this is the game module, so the game submission ID. And I'm just going to come here and I'm going to replace the data attribute with the data that I just copied. And I'm going to keep the user ID. This user ID is the user that I have on my side that's playing the game, the user that I was just logged in as, right? Because when you create submissions in Qork, it's going to use the user ID who's currently logged in as the user ID. Unless you supply a user ID, you can override who is the owner of a submission by passing in a specific user ID. So there's obviously real life use cases for that. Let's say you're a support person and you're creating a submission on behalf of a customer who's calling you. You can certainly do user impersonation in that sense and create things on their behalf. But in this case, I'm logged in as an API user that has system level access, but I still want to create it on behalf of a given user. So I'll come here and I'll just hit send, and I logged out. Wonderful. So I will, it is wonderful because that means that it's a nice secure system, and the API tokens in Qork do not stay alive for too long. Obviously, when you're building with tokens, the shorter the lifetime of the token, the better it is. If anyone were to happen to hijack that token, the fact that it's only valid for a certain amount of time means that eventually it's going to expire, and the window in which they can do something nefarious with your token is closed. So now that I'm logged in again, I'm going to submit it, and it's going to give me back data because it created a new submission. It gave me that new submission ID. Now I can hop over to my game, and I could pop in that submission ID, and I could see it's the computer's turn. Now, the computer isn't taking their turn because the game doesn't, I guess I did not build the game to kind of like pick up if at any point the computer was the turn and the game didn't keep going. So in this case, it's showing me, though, that it is turn 2 with the computer, this one being marked exactly as we had it in the submission revision, which then allows me to hop back over to my server-side debugger, drop that same submission ID because now it is the computer's turn, hit execute, and the module goes back, and I'm able to see an end-to-end view of what it did, what the computer did. So that is one way that you can use submission revisions to debug. In this case, it was a game, but imagine you have a workflow or just modules where you're collecting lots of information. And let's say you go from page 1 to page 2, and you get to page 2 and you realize something's wrong. Or let's say, better example, you go from page 2 to page 3, you realize something went wrong. What you don't want to have to do is you don't want to have to go all the way back to page 1, enter all the same information in exactly the same way that you did the first time to make sure that you get that same bug the next time. Wouldn't it be great if you could just restore exactly to where you were, hit whatever button you needed to hit and see what went wrong? Much faster way to debug than constantly, again, replicating it. I mean, imagine if every time, if I was running through these tests and I got 15 moves into the game and then something went wrong, and the only way for me to test what went wrong and try to debug the logic that didn't work there was to try to go through and play 15 more turns with the computer. Number one, that's not very time consuming. Number two, the computer's unpredictable, right? It may not make the same move. So admittedly, there were times where I had 2 users open and I would actually just take the same steps. I would be like, all right, well, Nick 1 and Nick 2, you just do the exact same moves. Again, very time consuming. Let me just jump to the point where I had a problem and get going. So think about using submission revisions in that manner as you go and as you build within Qork. Okay, but that was a year ago. Again, this game's a year old. And of course, Qork is getting better and better and better, and codeless architecture is getting better and better and better every day, which means there's even a better way to do it today that would have saved me even more time than I felt like I saved using submission revisions as a test. Okay, and that is something directly in your modules, and particularly in the data workflow, but it's also in calculators, decisions, maybe some other logic components, but most certainly, and most importantly, to me at least, it is in your data workflow. And that is another feature that we've talked about, but I think we're going to talk about a little bit different today. And that's the unit testing tool, or unit testing feature of some of these logic components. Now, in this case, normally, or as we've talked about unit testing thus far, it's really been about that. It's really been about testing. You know, you enter these tests in, and then every time your module gets saved, Qork's going to run those tests, and it's going to alert you if any of those tests break. Okay, super important when you're making changes and maintaining applications and ensuring nothing new that you do has any regressions to existing working functionality. So this is something that you should be consider, if not be absolutely doing all the time when you're inside of Qork. But the beautiful thing is, it doesn't just work after the fact. It works before the fact. And that's coming at it from two ways. Number one is oftentimes with unit tests, there's this concept of test-driven development, which says define your tests and then write your logic. So thinking about that from like, let's actually just jump in. Do I have any calculators in this? No, but let's do it as a calculator, right? So thinking about test-driven development, again, defining your tests first and then building your logic to satisfy those tests is a way to approach software development. So you can do that in Qork, right? So if I had an input and then I had an output, and I knew that whatever I wanted to do, if the input was 1, then I expect the output to be 2, right? So that is what I know the result of whatever this is. And then I can actually go and I could say, okay, well, it's input plus 1. And then I come down here and I run my test and it works, right? Let's say if I had done input plus 3 and I came down and ran test, it shows me 2, 4. Now that means it's not working. So let's say the first time I do it, my expected doesn't meet my actual. I come back up here, I continue to make changes until eventually my result is exactly what I expected. That's test-driven development, right? Now I know that my tests are passing and I'm done, right? Super simple in a calculator. Now let's talk about it in a data workflow, right? Because this is a very data workflow heavy application where data workflows, as I focused on last time around, are effectively functions, right? Rather than just the ETL jobs that people think about data workflows are functions. And I want to test those functions. And I want to actually test those functions a lot. And as I'm building them, rather than having to necessarily change a data workflow, save my module, go back to wherever it is, be it the server-side debugger or be it my UI, run through whatever steps, see the data workflow run and not do what I want. You know, that's a long cycle of making a change, test, running through the process to see the change, see that it works, great, see that it doesn't work, shoot, repeat, 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 right? Wouldn't it be great if I could do that and actually see specific changes to it throughout as I'm building? Right. So that's where I think the more exciting, as great as testing is, or the more exciting uses of the test harnesses is. So you'll see I've opened up my console. I'm just going to leave this open because, well, I'll get to why I'm going to leave it open. So the first thing is, how would I go about doing this? Okay, how would I go about using this to more or less, and what we're going to do is we're going to start through the take turn. So these are the 4 steps that happen anytime a turn is being taken. And I want to look at that specifically within my module and be able to inspect in depth what's happening. Okay. So the first thing I'm going to do, which I set up ahead of time, is this is the first data workflow that runs. And it says, these are the 2 things that are going to get hit. And this is the board that it's going to get hit against. So this here is just the JSON representation of a board. So again, I can grab that from any submission revision. So let's say I keep having the same problem where no matter what, so I'm going to use, this is going to be the game that I'm going to use as my example. Let's say the logic is, hey, when I click this, these two are supposed to fall, right? That's the logic of the game. But every time I click this, those two don't fall, right? I want to be able to hone in on that exact scenario and step through every single thing that happens to figure out why it didn't work. Okay. So what I would do is I'd grab the JSON of the board in this state, which is what we just did, right? We grabbed and we sent it to Postman to create a new submission. So it's this exact board object right here. So the first thing that we do, let me back over to my module, is I'm going to define that as my board. And for the temp X and temp Y, these are going to be the XY coordinates of the block that I'm going to hit. Okay. So I want to hit again 1, 2. I did not do 0 index typically for arrays. I kept it 1, which it's easy for folks. So I want to hit 2, 2, right? So this is the one I'm going to test hitting. So I'm going to come back, and this is the test I've set up. Given the board and these 2 hits, what happens? So I can come down here and I'll hit run test, and that's going to give me a temporary board. So it's going to run through the logic that happens here, and it's going to calculate my temporary board. And what that is, again, what this data workflow hit is, it says, hey, take in an X and Y and mark that XY as being hit on the board, and then end the game if that hit was the penguin, or in our case, the Qork, right? So now I have the temporary board. So this is what the board looks like after that 2-2 cell was hit. So that is going to be very important throughout all of our tests. So I'm going to copy that. Okay. And I'm going to jump into the next steps. This is the next thing that happens. Data workflow hit calls rows. Okay. I'll open up my unit testing here. And you can see I did a little pre-work, right? So once again, I'm going to say, now I want to take that temp board. So that was the output of the previous step. I'm going to drop that in as an input to this step. And then again, I'm starting with 2-2. That's the button that was hit. And I can run this test. So again, what this data workflow does is it says, give me a board and give me whatever XY coordinate has been hit and tell me what's adjacent to it to get the process started of calculating what else is going to fall based on a given hit. All right. So I will enter those as my inputs. I will run that test, and it's going to give me this. Now this, if I drop this over into JSON lint again, you'll see it's an array of 4 cells of my board. So I hit 2-2. So this is giving me 3-2, 2-1, 1-2, and 2-3. Those are the 4 that are adjacent to the one that I hit, because those are the ones that we have to start with checking. Okay, so that's our output of data workflow hit calls row. It calls rows. Let's jump to the next step, right? Data workflow fall loop. Okay, so this is actually what's going to go through and start processing each of those adjacent cells or adjacent blocks to see whether or not they've been hit. Okay, so this is just the looper to say, these are the ones I need to check. And then it's going to kick it over to the data workflow fall data workflow, which is actually going to check it, right? But this is just looping through. And then eventually when it's done, move on to the initial, to ending the terms. Okay. So coming down here, you'll see I again pasted in the result of the previous data workflow. My index fall, so this is an index. If you think about, with this loop being like a for I equals 0, I less than, whatever dot length, I plus plus, you're kind of 4. This is your I equals 0. So we're starting with 0 and we're saying the game is in progress. Okay. So when I run that test, what is it going to tell me? It's going to tell me that it's incremented the index by 1, as the I plus plus would in a for loop, right? Then it's going to give me the temp X and the temp Y that I'm going to check. So this is saying, hey, this is the first one. And if I jump back over to my JSON lint, not surprisingly, 3-2 is the first one that I'm going to check. Great. So now, interestingly, while you can't use this feature to necessarily loop, right? It's not going to process the next data workflow. So what happens again is when the loop is being for each iteration of the loop, it processes the fall. And then when the fall is done, that's what tells this loop to start up again, right? So those are dependencies across 2 components. So while technically I can't test that entire, dependent logic to iterate through my loop, I can at least just simulate that things are working correctly, right? So now I'm going to increment my index by 1. I run the test again, and now you'll see index is 2, and the XY is 2, 1, and of course 2, 1 is the next one, right? So you can play with your inputs to get different results out of it, right? But for our first time through, we're going to check 3, 2. Okay, that's going to be our temp X and temp Y. So now I'm going to jump down to my final data workflow of this process. Okay, and I'll come into the unit testing again. And now here's my inputs, just what I said I was going to do, right? Take that same temporary board, see 3, 2, and see what happens, right? Now, what should happen is if 3, 2 is supposed to fall, this data workflow hit should execute. And regardless, the fall loop is going to execute again. This data workflow is always going to tell the loop to start again. And then the loop realizes that middle condition where I is no longer less than the length or less than or equal to the length, however you want to write it. It will then just stop and break out of the loop. But it's not the fall's responsibility to know whether or not the loop is done. It's the loop's responsibility to know. So the fall is just always going to execute that at the end. But it will only execute data workflow hit if this block is determined to have fallen, because it doesn't, again, have that support that it needs. So if I come in here and I hit run, 3, 2, data workflow hit doesn't fall. So if we jump back, 3, 2 would be this one over here. So I hit this one. This one's still good to go, right? Because it has pressure from these two sides. So 3, 2, you're good, no problem, right? The next one in the list was 2, 1. So that's this one here. Okay, and since I hit this one, that means that this doesn't have pressure from both sides. It's missing adjacent sides are down, which means this one is going to fall. So I can come up here and I'm going to change this to 2, 1. And now, sorry, it would actually be 1, 2, right? I run it and there we go. It has been hit. Okay, so I can now see, did it get hit? Yes, it did. So you can run any number of tests you want to say whether or not a specific thing is going to be hit. So in theory, you could have one test for every single block possible in any single really or orientation of a board. You can set up as many of these tests as you want, and then you validate whether or not it's going to get hit. So if you go change logic somewhere else, you want to make sure that regardless of what other else changed in your module, the prospect or the process to determine whether or not a block falls is untouched and unbroken. Okay, so great way to do step through testing, and also then to keep it there and validate it later. But what I said was I'm going to open this console, okay, because I'm going to show you something in this console. What I think is the most amazing thing about this feature is not just that it tells you the outputs, but that it is actually executing your data workflow when you hit that button. Of course, it has to, right? Because it needs to output these values. So what does that mean? That means that anything that you put in this data workflow is going to run. So what if I were to grab a console over here? I'll grab a console. I'm just going to connect it to this filter. I'll come back down here, and I'll run my test. And look at that. In my console is the output of that filter. Okay, and what is that filter doing? That filter is finding the adjacent blocks for whatever block is being sent in. So these are the adjacent blocks, right? So that I'm able to view that data, and I can continue to add these consoles at every step of my process. I'll add it over here, and I can name these consoles. We'll call this one create field. This one we'll call adjacent or whatever, right? I come down here, and it's going to do both of my consoles, and it's going to name them what I named them, right? So Matt, just think, I hope this is hitting like what this is. So you don't need to really leave a data workflow to build a complete data workflow. You can build it iteratively without necessarily having to go save. Now, that being said, we all have been working with computers long enough. It's always wise to save your work every so often. So as you're going through this, hit save again. Make sure all that great work that you've done all this wonderful debugging on doesn't get lost. It's very important, but this is, I mean, any developer is going to want to be able to put breakpoints in their logic and ideally test without having to go in your browser. I mean, think about it, even if you're writing code and you want to debug logic in a UI, I mean, you still have to bring the UI up. You still got to go refresh your browser tab after you make the change to your code. You don't even have to do that in Qork. You can test that logic, whether it's server side or client side, all within your IDE, all within Qork's designer, and see what's happening along the way. So that's actually it. You know, it was an hour, a little over an hour last time, or 45. Feel pretty good about this. Those were the main points. Again, we wanted to get across here was, you know, one, you can build AI with no code. Two, there are so many debugging tools available to you within Qork, and a lot of people, I know people live in the console when they're looking at their modules in Express. They live in the server-side debugger when they're looking through debugging APIs. But now you don't even need to live anywhere else but Designer to get a lot of really complex stuff done and check a lot of your work as you go through and as you build in Qork. I'm looking over. We don't have any questions. If anyone has any questions, throw them in the chat now. I will just slowly speak for the next couple of minutes, see if anything comes in. But one way or another, I will take this opportunity to say, going forward, so next week, we're going to be here on Tuesday. So I know normally it's Thursdays at 3. We've been pretty good about keeping that. We're going to shake it up a little bit on you. We're actually going to try to do more of these streams going forward. Starting in June, we're really going to hit the ground running with bi-weekly, which actually apparently means something different in Europe than it does in America. Bi-weekly in America is every other week, right? Bi-weekly in certain other places means twice a week. So I'm going to use the European bi-weekly here and say we're going to come at you 2 times a week on Tuesdays and Thursdays. Next Tuesday is going to be at noon Eastern time. And we're going to have Danny Pankratz from our community, who leads our community, Qork's community, on to tell you a lot about the community. And then we're going to have some of our SMEs, some of our SMEs come on to answer some of the top questions on the community. There's so much great content out there. What an amazing resource for anyone who's building within Qork. So definitely stay tuned or come back next week to hear from Danny himself and the team about the community. And then we're actually probably going to take a little bit of a break. I'm going to be taking that stream next week from Italy. And then I will be taking a little bit of R&R after that. So it will probably be a one-time next week at 12 Eastern on Tuesday with our community. Do not miss it. Thank you again, everybody, for joining. And this time around, rather than happy uncoding, happy debugging. All right. Bye.